Hi everyone, I hope this unit is going well for you and that you are understanding. And of course, if you need help, please reach out to me. There's also lots of good resources on YouTube on ionic bonding and forming ions. So make sure that you are utilizing any resources that you can. I wanted to quickly just review ionic bonding and what we learned over the last couple days about forming ions. So remembering that ionic bonding is between a metal and a nonmetal. Electrons are transferred, ions form, and oppositely charged ions will attract to form ionic bonds. And then a prime example of that would be sodium and chlorine. So that one valence electron for sodium is transferred to chlorine. So sodium loses one electron to form a positive cation, Na1 positive. And then chlorine gains that electron to form a negative anion, Cl1 negative. Then once we have those ions form, we know that opposites will attract and those charges will cancel to form a neutral compound, NaCl. And I'm sure some of you probably discovered that NaCl or sodium chloride is the fancy word for table salt. So the next time you're at dinner with someone and you need to salt your food, just ask them to pass the sodium chloride and they will be very impressed with you. Today we are moving on from ionic bonding to talk about a new type of bonding called covalent bonding. Sometimes it's called cooperative bonding, but we're going to refer to it as covalent bonding. So covalent bonding is a bit different from ionic bonding. So we're going to talk about the ways that they're different first, and then we'll put some practice in. So the first thing that's different is that covalent bonds happen between two nonmetals, whereas ionic bonding was between a metal and a nonmetal. In covalent bonding, we're dealing with two nonmetals. Over here it says sometimes there are no opposites around to form ionic bonds. Oh no, but that's okay. Atoms will still find a way to get a full shell of 8 valence electrons. So we're still meeting that goal of having 8 valence electrons through bonding. Instead of gaining extra electrons, they share them. So in ionic bonding, electrons were transferred. In covalent bonding, electrons are going to be shared. Okay, so remember when we did our Lewis dot structures, we're going to be using them a lot with covalent bonding. So you see here that we have 2 oxygen atoms with their Lewis dot structures drawn. Remember that Lewis dot structures are showing us the number of valence electrons. So each one of these oxygen atoms has 1, 2, 3, 4, 5, 6 valence electrons. They want to have 8 valence electrons. Each one wants to have 8. They're not going to transfer electrons. Instead, what they're going to do is share those electrons through these bonds. If we have 2 bonds, it's called a double bond. Let's do some practice. So this says draw the covalent bond between 2 nitrogens. So I have a nitrogen atom here and a nitrogen atom there. So the first thing that we're going to want to do is draw those Lewis dot structures. If you're looking at your periodic table, you know that nitrogen is in group 15, so it has 5 valence electrons. I'm going to go ahead and draw nitrogen's Lewis dot structure. Each one having 5 valence electrons. So our nitrogen atoms want to have 8. But if these are the only 2 atoms in close proximity to one another, neither one of them are going to give up any one of their electrons because they're only 3 away from having 8. So instead of giving them away, what they're going to do is form bonds, and they're going to share those electrons. So this nitrogen atom now has 1, 2, 3, 4, 5, 6, 7, 8 because it's sharing those 3. This nitrogen atom also has 1, 2, 3, 4, 5, 6, 7, 8. So each one has 8 valence electrons because they're sharing some. And we're going to clean that up just a little bit, and our bond would look like this. There are 6 total electrons that are being shared. Within each one of these lines, each one of those bonds, 2 electrons are being shared. Then the way that we would write that formula, we have 2 atoms of nitrogen, so N, and then our subscript 2 shows us that there are 2. Let's draw for fluorine. So again, the first thing that we would do is draw our Lewis dot structures. Fluorine has 7 valence electrons. Okay, so they have 7 each. They want to have 8, but neither one of them is willing to give up any electrons. So they're going to share. Another note, electrons like to be paired together. So you see that those electrons are paired up. These are paired up, paired up. Same thing over here. We have a pair, we have a pair, we have a pair. So we have 2 lonely electrons on each one of our fluorine atoms. So this electron over here is looking for a partner, and this electron is also looking for a partner. So they're going to share a single bond together. And in doing that, that has satisfied each one of those fluorine atoms' need to have 8 valence electrons. We have 2, 4, 6, 7, and 8 for this fluorine atom. 2, 4, 6, 7, and 8 for this fluorine atom. To clean that up, we would draw F, one single bond in F, remembering that there are 2 electrons being shared in that single bond. And then the way that we would write that formula is F with a subscript of 2, meaning that I have 2 fluorine atoms in this compound. Over here, we are asked whether these bonds are ionic or covalent. So let's think about the difference first. I have my information for covalent right up here. Covalent bonds share electrons. It's between 2 non-metals. Ionic bonds transfer electrons.
Teachers, just a reminder, if you have not sent your trash out, please do it at this time. Thank you.
It's between a metal and a non-metal. So let's look at this compound first. Magnesium is a metal. Oxygen is a non-metal. So this would form an ionic compound. CO, we have carbon, that's a non-metal. Oxygen, that's a non-metal. That would form a covalent compound. Okay? So you can go through the rest of these on your own and decide whether they would form an ionic or covalent compound based on whether they have 2 nonmetals or a combination of a metal and a nonmetal. We're going to go ahead and move on and do a few more practice problems. So here is just some more practice. It tells you that each bond holds 2 valence or 2 electrons that are shared. It also goes through the steps about how to make those bonds. So we already did fluorine. We made a fluorine atom or a fluorine compound together, but I want to look at this one. So this says make oxygen difluoride. So the formula here is OF2. So I'm going to start by making my Lewis dot diagram for oxygen. Oxygen is in group 16, so it has 6 valence electrons. Fluorine is in group 17, so it has 7 valence electrons. Okay, so over here, oxygen has a pair here, those are happy. A pair here, those are happy. And then 2 unpaired electrons, they're lonely. Fluorine, 2 pairs, 3 pairs total. So all 3 of those pairs are happy because they have a partner, but we have one that is without. So this lonely electron is going to make a bond with another lonely electron over here on oxygen. But we still have 1 electron that is without a partner. Fluorine already has 8 valence electrons, 2, 4, 6, 7, and 8. So it can't share any more with oxygen. So what we have to do is bring in a second fluorine atom. Draw our Lewis dot structure. This has a pair. They're good. Those are paired. They're good. Those are paired. And we have one unpaired electron, which is perfect because oxygen also has an unpaired electron. So those will actually also form a single bond. So when we clean that up, you're going to have oxygen in the center with a fluorine atom on each side. 2 electrons are being shared here. 2 electrons are being shared here. Let's do another one. Let's take a look at CH4. So this is the chemical compound for methane. So I'm going to draw first the Lewis dot structure for carbon. Carbon is in group 14. It has 1, 2, 3, 4 valence electrons. Hydrogen is in group 1. It has 1 valence electron. Hydrogen only wants to gain 1 more electron because hydrogen's Bohr model looks like this. So it only needs 1 more electron to have a full outer shell. So hydrogen only wants to pair this 1 electron up with another electron. So right here we're going to form a single bond. So those 2 electrons are being shared and hydrogen's satisfied. It has 2 valence electrons, which is exactly what it wanted. But carbon still has 3 unpaired electrons. So all we need to do is bring in a second hydrogen, draw its Lewis dot structure, and that will form another bond. Same thing on this side. That will form a bond. Same thing at the top. That will form a bond. So when we clean this up, here's what our structure will look like. Central atom is carbon with hydrogen atoms on all 4 sides. These are 4 single bonds, and each bond is sharing 2 electrons. Those are covalent bonds. Now, if you're given the formula CH4, you automatically know what your structure will look like. I have 1 carbon atom, tells me that in my formula. If we were to show the subscript, it would be C1H4. The 1 is understood, so we don't see that written in chemical formulas. And then that 4 subscript tells us that there are 4 hydrogen atoms, 1, 2, 3, and 4. So what you're doing here is you're going to keep on pairing electrons together until every electron has a partner, and then you're going to want to make sure that each atom in that chemical formula has a full outer shell of electrons. Like carbon here has 2, 4, 6, 8 valence electrons, so it's happy. And then each of our hydrogen atoms only wanted 2 to have a full outer shell, and each one has satisfied that. 2 here, 2 here, 2 here, and 2 electrons for the 4th. That is covalent bonding. Now, just to reiterate, in covalent bonding, we can have 3 different types of bonds: a single bond, a double bond, or we can have a triple bond. Like here, a triple bond. This would be a single bond. Oxygen would be a double bond. Remembering that in each bond, 2 electrons are being shared. So I'm going to write this at the top. Single bond, two shared electrons, a double bond, four shared electrons, and a triple bond equals, 6 shared electrons. All right. Let me know if you have any questions, and best of luck to you.